Hi, I am Jedediah Pasco and I'm from 11 Navarro, and in this video we are going to talk about the application of derivatives, specifically related rates. Related rates are relationships between variables with respect to time. When dealing with related rates, knowing the basics of implicit differentiation is very important. Let's go over a few basic things associated with related rates, particularly derivatives. For instance, what is the derivative of y cubed with respect to x? In this case, we have to apply the basic rules of derivation, which is the power rule. This is denoted as nu raised to n minus 1. So let's apply that to y cubed. So this would be 3y squared times dy over dx. So that is basically what you will do when you are differentiating. Let's have another example. For instance, you want to differentiate x to the 5th power with respect to x. Let's apply the power rule again, and this will be 5x to the 4th power times dx over dx. However, we can cancel this out, so the final answer would be 5x to the 4th power. Now, if we want to differentiate x to the 5th power with respect to time, you have to change dx into dt to represent variable time. So again, apply the power rule, so this will be 5x to the 4th power times dx over dt. So this is the final answer. For related rates, that's what you are doing. You are going to differentiate the equation with respect to time. When dealing with related rates, you are going to encounter things like d over dt, dx over dt, or something with dt in it depending on the variable, because rates are usually dealing with units of time. By definition, a rate is basically how fast something changes with respect to time. Now, let's go to our worded problem. Maya is looking at a ball dropping from a building at a distance of 100 meters away from the base of the structure. If the ball drops at a constant rate of 2 meters per second, what is the rate of change of the angle between Maya and the ball when the angle is pi over 4? Now, before anything else, it is important to illustrate what is happening in the problem to further understand the situation. As the problem says, a ball is dropping at a constant rate of 2 meters per second from a building. Now, 100 meters away from the base of the building is Maya standing. So that would be 100 meters. And the angle of elevation between the ball and Maya, angle theta, is equal to pi over 4. Notice that this shape is considered to be a right triangle. So now, let's list down the given to know what we already have and what we need to find. The distance between the base of the building and Maya is considered as the x variable, which is equal to 100 meters. The y variable, or the height at which the ball is dropped, is not given. However, the rate of change of time at which the ball is dropping, or that would be dy over dt, is given, which is negative 2 meters per second. Negative because as the ball is dropping, the y variable is changing or decreasing. So since the direction of the ball is going down, so that would be a negative. So this is very important to remember always, to consider the direction of something. Now, the angle theta is also given. That would be pi over 4. Or if converted, that would be 45 degrees. The ultimate thing that we are asked to find is the rate of change of the angle between Maya and the ball, or shall we say, d theta over dt. So now that we have listed down the given, we shall proceed in finding, first, the missing variable, or the y variable. Now, a common assumption to solve for the missing variable, or the y variable, is using the Pythagorean theorem, or a squared plus b squared equals c. However, in this situation, the hypotenuse and the y variable is not given. So this equation would be hard to apply, or is not applicable in this kind of situation. But as we can see, there is an involvement of an angle. This implies that we can use trigonometric functions. So remember saw, katoa from our previous lessons. One of these three is applicable in solving our problem, which is TOA. This is equivalent to tangent theta equals opposite over adjacent, or y over x. Now notice that we have the values for x, and we also have the value for the angle theta. So let's rewrite the equation and apply basic math to create a brand new equation for the y variable. So the equation would be x tangent theta equals y. Now all we need to do is to input the given values. That would be x is equal to 100, tangent theta is equal to pi over 4. If you use pi over 4, make sure to set your calculator into radian mode, or if you would use 45 degrees, make sure to use a degree mode in your calculator. In this case, I will use 45 degrees. The answer is still the same even if you use a radian mode or a degree mode, so that would be 100 meters for the y variable. So now that we have the y variable, we can now proceed in finding d theta over dt, or shall we say the rate of change of time of the angle between Maya and the ball. So we can still use the equation tangent theta equals y over x. Now before proceeding, it is important to notice that as the ball drops, the x variable is not changing. This indicates that the x is a constant, whereas the y is a variable. This indicates that x is a constant and y is a variable, which has a rate of change of time. So we need to separate the constant and the variable. And that would be tangent theta equals 1 over x times y. Now that we've separated the constant and the variable, we can proceed and apply implicit differentiation. Now in this case, we have to differentiate with respect to time. So that would be d over dt in both sides. The derivative of tangent theta according to the rules of derivation of trigonometric functions is secant squared theta. So now let's multiply that to d theta over dt equals, now keep the constant, then the derivative of y is equal to 1. We can proceed in putting the dy over dt. Okay. Now again, before proceeding, notice that secant is not found in the calculator. Now always remember that secant is the opposite of cosine. So secant is also equivalent to 1 over cosine. In this case, there's a squared, so we should also put square theta. Now everything would still be the same. So now we can input the values and find d theta over dt. So let's list that down. Cosine the angle theta. If you wish to use this, always remember to set into your calculator into radian form or radian mode. And if you use 45 degrees, make sure to use degree form or mode. Now, cosine 45 degrees squared, d theta over dt still not found yet. Now 1 over x will be 100, 1 over 100, and dy over dt will be negative 2 meters per second. Now, before proceeding, let's first find the value of cosine squared 45 degrees. So that would be 1 over 1 half d theta over dt. Now this would be negative 2 over 100. So the answer would be 1 over negative 1 over 50. Now multiply both regions with 2. That will be cancelled out. So this would be 2 d theta over dt. 1 over 50. 1 half. To cancel out the 2 in this region. Okay. So now we will arrive to the answer of d theta over dt. And that would be negative 1 over 100. And the unit would be radian per second. So this is the final answer. In summary, the rate of change of the angle between Maya and the ball is negative 1 over 100 radian per second. Thank you for watching this video, and I hope you've learned something about the basic principles of related rates with an example problem. And this is my submission of our project given by our basic cal teacher, Mr. Del Rosario of Davao City National High School. Once again, thank you very much and God bless.